Hello everybody. In this tutorial we're going to look at how to convert between SI System International units and US Customary units, or vice versa, one way or the other. Please remember SI is what you used to call metric, but that's kind of an obsolete term now. It's called SI. Now, when we're talking about units, a fancy word for the units is dimensions. So when we are looking at analyzing the units of a measurement, we're talking about dimensional. Remember, that's just dimension is just a fancy word for unit. Dimensional analysis. Okay? So that just means unit analysis, all right? And what we're learning how to do is with our dimensional or unit analysis is we're learning how to convert from one form of measure into another form of measure of the same quantity. Okay? So, in order to convert from one dimension to another, from one unit to another, we use what's called a conversion factor. Now, you will actually also sometimes hear this called an equivalency. Equivalency. Some authors will use that term. But either way, conversion factor or equivalency, it's how one kind of unit is equal to another type of unit. And we can use that to help us convert. Now, look at an example. Suppose we have a measure of length, and that measure of length is 45.7 inches, and we want to convert to the unit centimeters. So we're going from US Customary to SI, okay? What do we know about inches and centimeters? What's our equivalency or conversion factor for that? Well, here it is. This is the conversion factor. We know that 1 inch is equivalent to 2.54 centimeters, okay? And that's what we're going to use to help us. Now, you are going to find a reference page folder in Schoology, in your physics class, and in that folder you will find a reference page for conversion factors, and that's going to be a very important page, so you probably want to print that out and put it in your folder for easy reference. Okay, so here's what we do. We take the measure, and yes, I know there's a typo there. I do that quite a lot. We take the measurement, and we're going to multiply that measurement by this conversion factor placed in ratio form. And the reason we place it in ratio form is so that we can cancel out the unwanted unit and leave behind the desired unit. And here's how we do it. As you know from math class, 45.7 anything, that can be seen as over and understood 1, just like any number in math class. And we're going to multiply by 2.54 centimeters over 1 inch. Now, why did I write it this way instead of 1 inch over 2.54 centimeters? Because if I write it this way, I've got an inch in the top, an inch in the bottom, and as you know, anytime you have ratios where you have an inch in the top and an inch in the bottom, the inches cancel, and that's going to leave behind the desired unit of centimeters. So now all we have to do is multiply across the top, divide by the bottom, which in this case is 1, and you get 115.8 centimeters when you multiply. Okay? So all you're doing is arranging the conversion factor into a ratio such that you can cancel from top to bottom the undesired unit and leave behind the desired unit. Okay? Now, look at the next one. It's a little tougher. Sometimes we have to convert units that are in more than one dimension. For example, squares or cubes. In this case, we have 30 square yards and we want to convert it to square meters. Now, the majority of conversion factor tables don't usually have squared or cubed units. They usually only have units of one dimension. So, in this case, what we're going to have to do is square it ourselves. So, to convert 30 yards squared, we need to put the yards on the bottom here and the meters on the top, and then we're going to square it. The value and the unit both. The value and the unit. Now, the yards squares cancel. You multiply across the top, divide by the bottom, and you get 24.3 meters squared. Isn't that nice? All right, we're going to practice a number of these. And the first two shouldn't be too terribly difficult, and you probably won't even have to look up a conversion factor because the first two actually deal with measurements of time. And we, in U.S. customary units, we already know a lot about how seconds in SI are related to minutes, hours, and days in U.S. customary units. So let's take a look. Right here, we have 0.45 days, and we want to convert to hours. And yes, sometimes in physics we do use hours, so it is important to know. But this is easy. Everybody knows how hours and days are related. You know that 1 day is equal to 24 hours. There's our conversion factor, our equivalency. So we're going to take our measurement. Remember, that's over an understood 1. And we're going to multiply by a conversion factor. Since days are in the top here, we want the day in the bottom. And we want the 24 hours in the top. Okay? So now the days will cancel out and leave hours behind. And if you multiply across the top, and of course you'd end up dividing by 1, you're going to end up with 10.8 hours. Okay? You're going to end up with 10.8 hours. Now, that wasn't so bad, was it? No, but, we already know a little bit of something about time. Now, look at the next one. Here, we're going to convert this answer to seconds. We're going to go from hours to seconds. So, what do we know about hours and seconds and how they're related? Well, believe it or not, 1 hour is equivalent to 3,600 seconds. Now, how in the world did I know that? Well, here's where you got to use a little common sense. You already know that an hour is equivalent to 60 minutes. And you also know that each of those minutes has 60 seconds. So you have 60 chunks of 60 seconds. So 60 times 60 is 3,600. You have 3,600 seconds in 1 hour. Okay, now that's our conversion factor, and we can take 10.8 hours and we can multiply 1 hour on the bottom so that the hours cancel, 3,600 seconds on the top, and we're going to be left with 38,880 seconds. So 10.8 hours is the same as 38,880 seconds. That's a lot of seconds, okay? All right, let's look at the next one. Now, these are a little tougher because not everybody tends to remember these conversion numbers very well. Miles to kilometers and pounds to kilograms, all that. Some of them, if you use them enough, you get used to them. It's no big deal. Time is the ones people remember the best. But these others, little trickier. So that's why I did put in your reference folder a reference page that has conversion tables on it for conversion factors. Now, in this particular case, 120 miles to kilometers, we know, and I'm going to go ahead and tell you already, that 1 kilometer is equivalent to 0.621 miles. That's the one we know. Or that's the one I'm going to use. You can also find it the other way, but in any case, we're going to use that one. So we're going to say 120 miles times our conversion factor. We want the miles on the bottom, okay? So 0.621 miles, and the kilometer on the top, so that now the miles cancel from top to bottom. And notice in this case, when we multiply across the top and divide by the bottom, we got to divide by the 0.621, don't we? Not multiply, so be careful. So we get 193.2 kilometers. How about that? Okay? All right, let's do another one. Let's use mass. Pound mass to kilograms. All right, what do we know about pound mass in kilograms? Well, some of you may remember this one from chemistry because you sometimes use it in chemistry with the gas laws. But in any case, we know that 1 kilogram is equivalent to 2.2 pounds. Okay? So we're going to take 180 pounds and we're going to multiply by a conversion factor that puts the pounds on the bottom so that they cancel. And the kilogram goes on the top. So again, look what you're going to have to do. This time you're going to divide 180 times 1 divided by 2.2, and you should end up with 81.8 kilograms for the answer. Okay? Now, the next one's going to be a little tougher because we want to go from miles per hour to meters per second. That means we want to convert the distance, miles to meters, and we want to convert the time, hours to seconds. All right? So that means we're going to need more than one conversion factor. So let's see what we know. Well, I don't know a conversion from miles to meters, but I do know a conversion from miles to kilometers. It's the same one we used above. And once I have it in kilometers, I can replace the K with 10 cubed to make it meters. That's why we learned how to go back to the base unit, see? Okay? In fact, what I could do right here is I could just say 1 times 10 cubed meters, there we go, that'll do it, equals 0.621 miles. That does it. Now we go from miles to meters. Now, what about the time? We want to go from hours to seconds. Well, we also know that 1 hour is 3,600 seconds. So these are the two conversion factors we want to use. So here we go. Now look what we're going to do. 55 miles per hour. Okay? Now, this time, we've got the miles on the top and the hours on the bottom. Okay, this is not a single unit like up here. We've actually got 55 miles per 1 hour. Okay? Miles per hour. So we have this per this. Let's start with the distance. We want to go from miles to meters. So up here's our distance. We put the miles on the bottom. And we'll put the meters on the top. Now the miles will cancel and leave behind meters, right? But we also need to convert the hours to seconds. So I need a second conversion factor. All right? So I want the hours to cancel. It's on the bottom here, so I have to put the 1 hour on the top here. And then the 3,600 seconds goes on the bottom. Okay? So I've got meters to miles, and I've got hours to seconds. And the units will all cancel except for the meters on top and the seconds on bottom. Meters per second. Okay? So multiply across the top, 55 times 1,000. Divide by the multiplication on the bottom. Okay, so you'll have to get this 2 and then divide it in. All right, and the answer, if you do it correctly, should be 24.6, all right, meters per second. So check it out. Try it and see if you don't come up with that. Okay? All right, last one. Let's do a multi-dimension. Let's look at length, width, and depth. All right, inches cubed to centimeters cubed. This would be a volume, wouldn't it? A solid volume. So that means we need to know a conversion factor. Well, I don't know a cubed one, but I do know from, let's see, where was it? Oh, right up here at the top. I do know from our example right here that 1 inch is 2.54 centimeters. Okay, so let's look at that. We know that 1 inch equals 2.54 centimeters. So if we have 23 inches cubed, then we want the inches on the bottom, and we want the centimeters on the top, and now we're going to cube, 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 cube. All right? 1 cubed is cubed, so you don't really have to worry about that one much. But you are going to have to take 23 and multiply by 2.54 cubed. So you should be able to do that on your calculator. And if you do it correctly, you should get 377 centimeters cubed, a measure of volume. Okay? I hope this has helped. There is a practice handout attached. Why don't you give that a whirl and see what you can do? If you have questions, you can message me and we'll take a look at it. Thanks a lot.